Okay, we're going to start talking about a concept called logic. In Thai, that's takasat, right? Um, and logic talks about whether things are true or false, whether things are real or not real, in a sense. Okay, and logic is made up of propositions, and proposition is tied is paput. Okay, so you need to know that for your own the proposition is a statement that can be true or false. So in some way, you can kind of think of it like when you're studying in English class, they teach you about fact and opinion. So it's kind of like a fact. A fact can be true or false. So in the same way, it's kind of it can be it's a statement that can be true or false. And logic comes with connectors, things like and, or not. And this stuff is really hard to understand. Um, I mean, it's not that difficult, but it's a different way of looking at math. So before we start, I want to compare what we've done in set theory already to logic, because we spent 6 weeks on set theory, and so. So set theory, we looked at things like uh, is an element, change my color here, is an element part of an is A an element of the set A, or is A an element of the complement of A, not A, or sometimes we'll use C here. What is A union B? What is A intersect B? What is the difference A minus B? And you'll remember that when we talk about let's say there's a set right here, and the set is called A, and in our set we have some numbers 1, 2, 3, 4, and then we have some numbers outside 5, 6, 7, and 8, and we can make the statement that that some element that's one of these is an element of A. So let me make the statement that 1 is an element of A. 1 is an element of A, or we could write that formally as 1 is an element of A, but I want to write it in English here because logic we're going to be using mostly English sentences. So 1 is an element of A, and I can see 1 right here. So that is true. Now if I change this and I say 5 is an element of A, we can check over here and see that is false. And if I want to write that formally, I'm going to say 5 is not an element of A, right? So the statement 5 is an element of A is false. A is an element of not set A, is not an element of set A. There's one way we can write it. So here I can write this as 1 is not an element of A, and you can see that's not true, that's false, and that's the opposite of the one we got up right here, right? 1 is an element of A is true, so 1 is not an element of A is false. But that makes sense. It can't be both. It can't be in and out the way we learned, right? It has to be true or false, that statement. And then if I make this statement, 5 is an element of I forgot the not here, is not an element of A. Erase that. We'll write it nicely, make sure everybody can. 5 is not an element of A. Well, that's a true statement. We use T for true, ding, and false for F for false, ted. Okay, so but we can see that this first one was false. It's an element of A is false, so it's not an element of A is true. It has to be one or the other. It can't be on the line and kind of in both places. You can't do that, right? Well, let me add another set here. Nine and 10, and we'll call this set B. We've done this a lot before, so it shouldn't be too hard for you to understand. So over here we have A union B, and we used to call that OR. Remember, I used to tell you all the time, it's A or B. It's A or B. So over here, if I choose an element like, let's choose a new element, 9. I want to make this green. 9 is an element of A or B. Now, how will we write that? We'll write that as 9 is an element of A or B, A union B. And A union B is everything in here. So it's in B and it's not in A, but it is in A or B. It is in A union B, so this one is true. And let's see, let me find one that we haven't done yet. 6 is an element of A or B. And we write that like 6 is an element of A union B. And union means or. So it's in A or it's in B, but 6 is not in either. 6 is not in A and is not in B. So this one is false. So we can see how union works with or. Let's remember how intersection works with and. And is just this part in here, right? So now if I say 9 is an element of A and B, if that's my statement, and really this is two statements. 9 is an element of A and 9 is an element of B. And this one above here is really two statements, and when we're connecting them with an or, 9 is an element of A or 9 is an element of B. Okay, so 9 is an element of A and B. It's in B, but it's not in A. It's not in this intersection here, so that's false. How will we write that? 9 is an element of A intersect B, and 4 is an element of A and B. And 4 is in A and 4 is in B. 4 is an element of A and 4 is an element of B. 4 is an element of A and B. That's the same as 4 is an element of A and 4 is an element of B. That's the same meaning, and that's true. Okay, that's true. And we could do the same thing for minus here, the difference. So If we take A and we take everything that's in B out, then we'd see that 2 is an element. Of the difference of A and B, A minus B, and that would be true because it's over here and we take out all of B. All right, remember we take out all of B and we're just left with that part of A. Okay, but then if I choose 3 and I say 3 is an element of A minus B, then that is false. Oh, I forgot to put the T here. So that one is false because it's in B. It has to be in A but not B. This is in fact the intersection of A and not B. Another way to write it. Okay, so that's kind of like connecting the two. So let's think about some things. I have a really bad hand here. But I have the names of the fingers, and some things are fingers and some things are not fingers. So I can make a statement. Blank is the name of a finger. And I'm just gonna write the word down here, but then we're going to make this statement. And this is a good statement. This is called a proposition. And this is called a good proposition. All right, this is a good proposition. This is a proposition. But we could state this some other ways, like tell me the name of a finger. And that's a command. That doesn't actually, that can't be true or false. That's just giving you a command. Comme ça, right? Or is middle the name of a finger? Okay, that's a question. That's not a statement. It can't be true or false. So we have to be careful that things like these are not propositions. Okay, so if my first proposition is index is the name of a finger, is index in this names of finger set? Yes, it is. So that is true. Is pinky? I'll give you a second to think about it. Is pinky true? Well, yes, it is. Pinky is the name of a finger. So that's true. Remember, I'm just going to read this whole sentence here. How about thumb? According to this set, I mean, maybe you think thumb is a name of a finger. Thumb is the name of a finger, but according to this this definition right here, that is false. And my last one, big toe, is the name of a finger. That's obviously on your foot, and in English, those are toes, not fingers. So that one is false. Now we're going to look at something that came from our test, and I'm gonna make some bad statements here that aren't propositions. Let's see. First of all, I'm going to ask a question. Does Olivia like Megadeth? And maybe she does. You can answer yes, but that is not a proposition. Because it's asking a question. It's not making a statement. Let's see. Who likes Blackpink? That is also a question, so that is not a proposition. If I give a command like name someone who likes Justin Bieber, I spell it right. That's a sentence. That's an affirmative sentence, but it's called an imperative in English, and this is not a proposition because it's giving you a command. Okay, so if we want to name some propositions, we're going to have to say something like so and so likes some person likes some band. Okay? And that's going to have to be the kind of statement that we have. So we can make a statement like Ava likes Justin Bieber. All right, can you look here? Can you find whether that's true or not? Well, here's the likes Justin Bieber set. Does Ava like Justin Bieber? Yes, she does, so that's true. And let's see, Sophia likes Megadeth. Is that true? Can you find Sophia? Does she like Megadeth? She's up over here. She's in Blackpink, and she's not in anything else, so no. That's false. Let me see. Mila, my last one here. Mila likes Blackpink and Megadeth. Let's see. Mila is up here. She's in that Blackpink set, and she's in that Megadeth set. So that's true. And really, I can write that as Mila likes Blackpink and Mila likes Megadeth. And that's the way we do it in logic here. So that's my introduction about logic. Trying to help you understand how that works with sets. So we're going to move on to some other stuff.